of the built environment. Hello, everybody, and welcome to the Sustainable Places event series at the Bartlett Faculty of the Built Environment here at UCL. I'm Joe Welch, the KTP Program Manager for UCL's Innovation and Enterprise Department, and I'll be hosting this event. Sustainable Places is the new monthly online event series led by the Bartlett, where we invite leading thinkers in the built environment to explore all aspects of the climate crisis and how it intersects with the built environment, from sustainability and green design to climate-adapted cities and housing. Today, you have joined the September event of the series, Sustainable Places, Partnerships for Green Design. Before we begin, a little housekeeping. The session is captioned live by a professional human captioner. If you wish to view the caption on a separate browser window, please click on the link shared in the chat. The event is being recorded. The recording and transcript will be added to the Bartlett YouTube channel and forwarded to registered attendees after the event. So for the format for today, we're going to present for the first part of the session and then followed by a quick Q&A before ending promptly at 2 p.m. We encourage you to submit a question for the panel at any point during the session by clicking on the Q&A function at the bottom of the screen. So in this Sustainable Places event, we're going to be exploring partnerships for green design. There are many routes for external organizations to partner with UCL academics in order to find solutions to the challenges they face. Today, we'll be focusing on the Knowledge Transfer Partnerships funding mechanism. Somewhat unsurprisingly, it turns out I am much more concise when heavily edited. So to maximize the time for our panel, I will cheat slightly by starting off my presentation with a short video explaining the KTP scheme, and then following that with an even shorter video describing the benefits that the participants saw in a recent KTP project between UCL and the architecture practice, Alfred Hall, Monaghan Morris. So it's my pleasure to welcome to the virtual stage, Dr. Esfandia Berman, Associate Professor at the Bartlett School of Environment, Energy and Resources here at UCL. Then we'll have Dr. Simon Hatherley, Senior Building Performance Architect at Alfred Hall Monaghan Morris and a former KTP Associate. And finally, we will have Dr. Qiuqian Liu, Associate Professor at the Bartlett School of Sustainable Construction, UCL. So I'm going to start by sharing my slides. So hopefully you're all able to see that. And let's just start with the first video. My name is Joe Welch. I'm the Knowledge Transfer Partnerships Program Manager here at UCL. One of the many opportunities that the Innovation Enterprise Department offers at UCL is the Knowledge Transfer Partnership Scheme, which is also known as KTP. A KTP provides the funding and support for a UCL academic to work with a partnership organization. Together, you'll be supported to apply for funding to apply your research for 1 to 3 years in order to develop a new product or service or even an efficiency saving. KTPs have been designed to take an academic and link them with an organization. And the aim is to take the specialized research and embed it into the organization to perform a strategically important innovation project. One of my favorite things about KTPs is the massive breadth of projects that we support here at UCL. Our team has helped secure funding for UCL academics across the whole of the university. We encourage submissions from all areas of research, and we also encourage academics at any point of their career to apply. Another good point is that you don't have to be in the same department as the other academics. In fact, multidisciplinary KTPs are often the most interesting of the bunch. KTPs have been around in some form since about 1975. Currently, they're supported by Innovate UK. Depending on the size and the type of organization, Innovate will fund 50 to 75% of the total project costs. KTPs benefit from a really high success rate. We have over 90% of our applications successful, and our academics enjoy it so much that they often do another one. As an academic working on a KTP, you will get a huge amount of support from our team, both pre and post-award. We'll help with the collaboration agreements, helping assemble gaps in the team, minute-taking at the official meetings, dealing with invoices and HR matters in the background. We can also help with spreading the word through UCL's comms channels, creating case studies, interviewing participants, and using UCL's social media channels. By supporting you with the paperwork, we give you more time to focus on the project. Comprehensive support not available at other programs. A KTP has at least 2 academics, a supervisor and a lead. The supervisor has weekly meetings with the associate, monthly meetings with the organization, and then a more formal meeting called a local management committee once a term. The academic lead needs to be at the formal local management committee meetings every term, but they can get as involved as they like. The team is also assigned a knowledge transfer advisor from Innovate UK who acts as a mentor for the whole team. The KTP associate is a UCL employee who's based at the organisation, but they can spend some of their time at UCL if needed. The organisations you work with must have a significant UK footprint. They can be a business or they can be a non-profit of any size and in any sector. There are even some opportunities to work with public sector organisations. The organisation needs to be large enough to properly support the associate and to be able to fund the project. So generally we think about 5 people or more. Think step up rather than start up. The most common arrangement is for an organisation to approach our office looking for academics to collaborate with, but it can work the other way around. There are generally 7 funding rounds per year, so roughly every 2 months. It takes about 6 weeks to go from a kick-off meeting to a fully fledged application, and the whole process takes around 9 months to get all the pieces in place before the project really starts. To find out more, just take a look at our web pages.
Okay, thanks for that. And then the next video is a case study on our using KTP with AHMM.
My name's Simon Hatherley. I am an architect and researcher. The opportunity came up to get involved in a knowledge transfer partnership looking at approaches to developing large-scale net zero carbon buildings. Fortunately, I was accepted onto the KTP, and at the end of that KTP, I was employed by AHMM.
AHMM is Alfred Hall Monaghan Morris. We are architects. We're a general architectural practice. We're one of the largest in the UK. We work across sectors, across scales, across building types. KTP project came about from trying to understand what zero carbon buildings look like in large-scale, mixed-use, commercially driven urban projects.
One of the outputs of this is the Net Zero Carbon Guide, and it's been really great going out to industry and finding how they've responded to it. And the fact that I was kind of embedded within AHMM's building performance team meant that I was kind of interacting with project teams and engaging with some of the kind of day-to-day issues as well as kind of the grander issues of achieving net zero. In terms of kind of benefit for your career, it's great in that it kind of allows the researcher to kind of engage with practical research questions, but also the kind of high-level strategic issues.
I see the KTP as a perfect link between fundamental research and applied research. So it gives us the opportunity to make our research more useful, practical, in collaboration with an industrial partner.
In terms of kind of the structure of the team, there was the academic supervisors and the industry team who I engage with on a daily basis. There'd be more formal meetings to review the progress of the KTP, meetings with the academic supervisors. On top of that, you'd have LMC meetings to kind of present to Innovate UK. But there was also support in terms of admin aspects of delivering the research.
Personally, I found our KTP team very agile and very responsive. We thought that that's because probably our KTP team are also interfacing with the industry. So in terms of the responsiveness, they feel the demand, from the industries. They have a fast turnaround and they have to be quite agile.
I think the kind of combination of the academic team with the KTP office and the Innovate UK advisor was a really strong team to help kind of guide us through this process, because whilst we do research at AHMM, we're not in that kind of academic world, kind of reporting world, so it was really helpful to be guided through that. The KTP office at UCL were great. They're really supportive of what we're trying to achieve and offered good guidance when we were getting a bit stuck, and particularly sort of the very tight methodology of reporting required for the KTP. It can be quite a bureaucratic process, so they were really helpful around that.
For businesses, it's a way of bringing new knowledge into a company and kind of tapping the resources and expertise of academia.
The KTP process and bringing your research into the practice enabled us to kind of validate our thinking and our ideas. Embedding our ideas in kind of academic field of knowledge actually helped sort of validate them and give them a kind of credibility and a robustness that perhaps they otherwise wouldn't have got. From a researcher's point of view, Simon has now joined our company.
My role within AHMM gives me scope to explore continued relationship between academia and industry. We're supporting project teams dealing with the realities of sustainability, but also there's some kind of bigger questions. And certainly one of the benefits of the KTP and its relationship to this role means that there is that scope to kind of explore those sorts of issues.
Okay, well, thanks for your attention for that. If any of those sounds interesting to you, please get in touch with the UCL KTP team, or if the KTP structure isn't quite right for your project, it could be that there are other knowledge exchange mechanisms that we can try and help with. So enough from me, and I will stop sharing here and hand over to Esfand for the first of our talks.
Hello, everyone. Thank you very much, Joe, for this very nice introduction to KTP schemes. My name is Esfand Berman, Associate Professor at UCL Institute for Environmental Design and Engineering. I was involved in this project, as it was explained in the videos, as academic supervisor. So it was a partnership between UCL, IED, and AHMM architects to better understand the requirements and the pathways to achieve net zero greenhouse gas emissions in high-density, mixed-use commercial developments. So the rationale for the partnership really emerged from the fact that, I suppose for AHMM architects, it was valuable to tap into UCL resources, the expertise that exists within the Bartlett and our past research. For us, the project provided an invaluable opportunity to look into real-world case studies, the latest trends, the state-of-the-art, the technological measures available to get to net zero, but also to have a better understanding of the challenges ahead and what needs to be done research-wise to overcome these challenges. So throughout my brief presentation, I'll try to provide a little bit of context, and then Simon in his presentation would be able to delve deeper into the outcomes of the KTP, not least the net zero guides that he was also referring to in one of the videos. In terms of the definition of net zero carbon in the context of buildings, it's probably best to start with operational energy and operational carbon. So put it simply, net zero carbon building operationally means that the balance between direct and indirect greenhouse gas emissions and the displaced emissions through microgeneration on site or carbon credits and offsetting emissions is effectively zero. So on balance, there won't be any burden in terms of excess greenhouse gas emissions related to the operational performance of buildings. The key to get there within the context of an increasingly low carbon electricity grid in the UK and most advanced economies is basically to electrify building services. I'm sure most of you have heard of the fact that we are trying to replace gas-fired boilers, for example, with heat pumps, other electricity-based technologies, and so on and so forth. So phase out fossil fuels such as natural gas, oil, or any other fossil fuel, and rely on electricity. And at upstream, we are trying to decarbonize electricity generation even further. So there are different scenarios for decarbonizing the national grid. So what is depicted here in terms of expected decarbonization of the grid by 2050. Of course, it's a very simple illustration of a conservative estimation of what is achievable by 2050. So the supply of net zero carbon energy as things stand right now through the grid is basically here. And ideally, throughout that realistic and rather conservative scenario, it's not even our central estimate, it's a conservative estimate, we would expect to be able to get to this level of energy generation by 2050, based on nuclear technology to provide a healthy baseline electricity, topped out by various sources of mixed of renewable energy generation, and of course, increasingly utilizing different types of energy storage to be able to respond to demand. At the same time, the demand, of course, needs to come down to meet the supply at this point. So we are dealing with transformation of the grid. As you can see, within less than a decade, we managed to decarbonize our electricity grid by almost 70%, somewhere between 60 and 70%, and we are on a nice trajectory to further decarbonize the grid. And at the same time, we need to appreciate that this decarbonization relies on a combination of upstream measures, so system transformation, but also demand-side measures, consumer transformation. So a combination of these measures would hopefully get us there. And again, the projection is not the best case scenario, is a rather conservative one. So we might be able to allow for a more disruptive, if you like, system transformation by means of developing hydrogen infrastructure and so on and so forth. Thereby, we would be able to even further decarbonize the grid. But as things stand right now, it's basically based on a rather conservative estimate that we are fairly confident we would be able to achieve. Based on that, if we follow a top-down approach, based on what we believe is fairly achievable in 2050, we would be able to develop targets within the building sector for different types of buildings based on the energy flows within the economy and the weight of buildings against other sectors of the economy. This is, for example, the targets for energy use intensity in office buildings developed by the UK Green Building Council. So you can see the absolute values on the left-hand side, translated to ratings in energy certification schemes on the right-hand side. So what we do, in addition to these top-down calculations based on the capacity of the grid for zero carbon electricity, is to complement them with bottom-up calculations, realistic calculations in each building sector to see what is achievable given the functional requirements in every specific building typology. So far, what I have basically explained and described is to do with operational carbon emissions. It's very important to understand that operational stage of buildings is only one stage within the life cycle of each building. So it's quite important to appreciate, for example, the embodied carbon in the construction material, the so-called upfront carbon that we use basically when a new building is developed, but also the carbon or greenhouse gas emissions associated with demolition, waste and disposal, and so on and so forth. So the intricate relation between operational and embodied carbon is something that we are aware of. The industry is trying basically to control both, and there are different institutions and bodies that are trying to develop key metrics, key performance indicators and targets for these, such as the targets set out by the Royal Institute of British Architects. But at the same time, very often, up to now, we see that these KPIs and targets are applied rather in isolation. So it's very important to understand the intricate relation and develop a holistic and integrated approach to operational and embodied carbon, adopting a whole life cycle assessment methodology. So this is what we're trying basically to do with AHMM through the KTP project. Now we embarked on a PhD program, again, a research project after the successful completion of that project. So it's a long-term and ongoing and very nurturing, actually, working relationship. We are trying to develop this holistic and integrated approach to say that through the development of a new building, or indeed even a refurbishment of an existing building, we are dealing with a certain amount of upfront carbon, for example, in new buildings associated with building material. After completion, of course, we have to deal with the operational energy use, the definition of operational, basically net zero carbon was touched on before in this presentation. But we're going to have a number of refurbishment rounds as well. For example, to do with building services, because building services typically have shorter lifespan compared to the life expectancy of the shell and core of the building. And then gradually, throughout the building life cycle of, say, 60 years, a typical assumption for commercial buildings, we need to have other refurbishment rounds to do with material as well. So we need to add all these embodied carbon elements to the operational carbon. And then when it comes to dismantling and demolition, again, excess in greenhouse gas emissions. When it comes to material recovery, hopefully, if we have adopted and deployed circular economy and resource economy principles, we would be able to recoup some benefits in terms of greenhouse gas emissions. And then in the end, still, we have some excess in greenhouse gas emissions. We need perhaps to use offsetting schemes to be able to overcome those, to have a truly net zero carbon building in the end. So this distinction is very important, because if you see zero carbon buildings only through a lens of operational carbon, you miss this picture of building up of greenhouse gas emissions throughout the whole life cycle as a result of embodied carbon, be it upfront carbon, be it refurbishments, and so on and so forth. So we try to basically come up with a working prototype based on this framework and develop a net zero guide for architects around this framework to appreciate and basically adopt this holistic approach to operational and embodied carbon. This was published last year by AHMM Architects. Is freely available to everyone interested through their website. And there are a number of case studies also in the guide, not least Canada Water, which for us was a specific case study that represented all complexities around mixed mode, large-scale commercial and residential developments. And we try to identify different pathways to net zero carbon in this building. To just finish my presentation by showing a slide that identifies a pathway to zero carbon emissions in an existing office buildings in London. This is a project that we are involved in right now. It represents a typical office building between typical and good practice standard air-conditioned office building in the UK. And as you can see on the left-hand side, even if we allow for decarbonization of the grid and basically adjust the energy figures based on projections for climate change, we have significant excess in greenhouse gas emissions, as you can see. So actually the green curve shows the ideal pathway to net zero by 2050, but we are well above that. So we figured out in this building, in which building services systems are almost at the end of their useful life, so there's a good opportunity to renew building services strategy, but at the same time, reduce the demand for energy by applying passive measures, so applying good practice measures in terms of building fabric. Put together, we would be able to bring down greenhouse gas emissions significantly and delay the point of at which the asset will be stranded, i.e. the greenhouse gas emissions will be above the ideal pathway to 2037, as you can see. So we can delay to that stage, to that year, but still, as you can see, there will be some residual emissions, excess in greenhouse gas emissions. So before that stage, we need to deploy other technological measures or start thinking of behavioral strategies to further decarbonize the building. Just wanted to highlight this to show how difficult it is to get to those targets that I just mentioned before. The target, for example, set out by the UK Green Building Council is not easy to get there. It's quite challenging. And what I'm, again, illustrating here is to do with operational carbon. Don't forget that with all these measures, replacement of building service technologies, anything to do with building fabric, adding insulation, of course, we are adding to the embodied carbon as well. And we need to start thinking of offsetting that carbon. So this integrated approach and view to operational and embodied carbon and achieving net zero carbon is really essential and something that AHMM and UCL are working on. And basically, we developed that guide as a result of the KTP project, but now we are working also on the case studies such as White Collar Factory, another brilliant building designed by AHMM. As we speak, we have a PhD project, and our PhD researcher is working on this building to see how we would be able to deploy demand-side management techniques and utilize, for example, smart ready technologies to further decarbonize this building and hopefully achieve net zero carbon targets. So just to sum up, I just want to highlight the fact that we are dealing with a very complicated problem, especially when it comes to this type of large-scale commercial buildings. So it's not only a technical problem, indeed is a techno-socio-economic problem, and we need different parties, different entities, different organizations to collaborate with each other. For that reason, this type of partnership represented by knowledge transfer partnerships and the funding available through Innovate UK has been really fundamental to further develop our understanding of net zero buildings and what it entails to get to that level in terms of building performance, because the vast majority of projects, even new builds and existing buildings, are nowhere there. So we need to do a lot basically to facilitate this transition to net zero. I'm sure Simon would be able to provide further details and go through the guide that was developed as a result of this KTP project. Thank you very much for your attention.
Oh, thank you, Asfan. That was very interesting. Moving swiftly on then, well, our next speaker is Simon. If you can come on and share your slides, please.
Okay, great. Thanks, Joe. So yeah, I'll be talking mainly about the Net Zero Carbon Guide, and as Estefan said, I'd encourage you all to download it. It's freely available. Just a quick introduction to AHMM. AHMM is the 4th largest architecture practice in the UK. It was a founding signatory of Architects Declare, which was kind of part of the background to the KTP, and you know, the KTP was seen as one way to kind of fulfill the requirements or fulfill the aspirations of Architects Declare. It was a collaboration between AHMM and IADE, and as I said, the guide is the main output, but we're currently in the process of developing a toolkit. And the toolkit builds on some of the key diagrams from the guide. The main net zero carbon diagram that was just shown by Esfand, and which I'll be touching on, but also the carbon square, and it makes those tools, those diagrams live and in a way that can be applied to bespoke to a specific project. As I said,
just had a request to put your slideshow on full screen if possible.
Yeah, sure.
Just a little bit below on the previous menu.
Where are we?
Left and down a few. Keep going down. What on this menu? Oh, sorry. Or just press Control and L.
Yeah. Okay. Yeah. Great. Thank you. So yeah, I'll be talking a bit about the context of the guide, how it's a portal to other sources of information that is fundamentally based on the use of a whole life carbon approach, some of the strategies that are kind of advocated within the guides. It's the link of net zero to other systems, some of the key principles and some of the summary and key points that come out of the guide and the research in general. Essentially, one of the kind of the guide drew on a number of different sources, including modelling by AHMM's building performance team. There we had input from UCL's MSc students, their research and their dissertations. We had, over the course of the research, we had 4 MSc students who provided kind of support. We had a series of workshops with consultants and architects, and there was kind of an investigation of net zero carbon building standards and some of the literature around net zero. And as Esfand touched on, we're kind of at a point where industry was part of the response of industry to this requirement for a net zero carbon built environment was the development of standards and frameworks such as the RIBA 2030 challenge and LETI, and currently we're in the process of a kind of big kind of cross-industry initiative, the UK Net Zero Carbon Building Standard, which is due to be published at the end of the year. And also you had a whole range of guides and publications that were out there kind of advocating or kind of investigating net zero carbon approaches. And the net zero carbon guide was intended both to kind of draw on those sources, but also be a resource that would support the reader in kind of taking the reader to those sources. So essentially it could be read at several different levels. It could be read at the level of a skim. So you could find, if looking for key pieces of information, but actually if you wanted to do a deep dive into something like grid decarbonisation, net zero carbon buildings, you could do that. And the guide kind of highlighted the challenges of delivering net zero, and because it was grounded in a real life project, Canada Water, that Esfand just showed, it did consider some of the trade-offs and strategies and some of the challenges of delivering net zero with reference to a real world case study. The research, one of the kind of challenges at the outset of the research was defining net zero. And as Esfand explained, the approach that we took was essentially one of a whole life carbon approach, recognizing that you've got this emission of, you've got the emissions at the outset of a building's life through construction, through the manufacturing of mining of materials and taking them to site, which we refer to as the upfront carbon. You've got the operational emissions, either the emissions from both direct and indirect from the burning of fossil fuels over the course of a building's life, from the operation of the building, but also things like the F-gas, the fugitive gases that might come from, for example, MVHR equipment. And as Esfand mentioned, you've got those upticks from the changes that occur over the life of the building, things like refurbishment and retrofit and refits and all of those kinds of things, those changes that occur over the life of a building. And then you've got the emissions that are associated with demolishing or dismantling a building at the end of its life. But then you've got your mitigation measures such as recovering material from the building at the end of its life, and of course the offsets. And it was kind of one of the interesting things that we were able to explore, especially with the help of the support of the MSc students, was that we were kind of able to start considering that actually at each one of those points there is scope for a performance gap, and kind of an important part of the research was kind of getting that out there and kind of recognizing that. And another kind of aspect to the research was that actually with reference to a real world case study and also reference to the work of AHMM, we were able to start looking at or investigating some of the kind of key strategies that designers can employ to achieve net zero. And that, fundamental to that was kind of establishing benchmarks at the start for both operational embodied carbon and the use of iterative design approaches. It was also about kind of, when we're thinking about the upfront, employing the principles of economy and efficiency and elegance. That's kind of using only as much material as as is needed, and kind of getting rid of kind of superfluous material, things like suspended ceilings that are hiding services and those sorts of things. It was also about kind of saving where possible, substituting materials such as GGBS for cement, or using carbon sequestering materials like CLT. And then in terms of the operational energy, it's kind of considering the building form and envelope, and also the relationship of the building users to control systems, and also approaches to monitoring performance. And then when we're kind of thinking about the in-use carbon, this is kind of thinking about considering future flexibility at the outset, and also considering adopting a mindset that views the building as a future resource bank, and that's kind of tied to recording the characteristics of the building and the materials, and considering end of use and material recovery. And of course, there's the offsetting bit, but one of the things we always try to get across was the fact that that this is kind of the final step, and this is kind of one of the kind of elements where there is the most risk, because there's, you know, when you've got risks of reversal associated with offsets, that, you know, from things like when you're considering tree planting and those sorts of things, that you know, you've got you know, trees can die from disease, you can have fire, and all of those other things that mean that carbon that you might think is securely locked away can be released. And as I said, this is kind of the bit that one of the things we wanted to get across is that we shouldn't be relying on this. We should be really going as far as we can to adopt those other strategies first. And it was also important to recognize that the building is part of a wider system, and a system that's kind of connected to systems of production and systems of energy production and transmission. And those systems will play a kind of key part in a building achieving net zero. And as I said, like we're kind of used to the idea of building systems such as ventilation, MVHR systems. But when we're kind of thinking about net zero, we kind of have to go beyond that and actually start engaging or considering the systems of production, the fact that decarbonized manufacture is playing an important part in the kinds of products that we specify and the information that we ask for from manufacturers. And also important is the systems of energy generation and transmission, and the decarbonisation of the grid is kind of one of the most significant factors feeding into net zero. But with that come significant risks as well. So we've got risks around variability of supply, and there's a whole question about how we respond to that. And when we're another kind of interesting aspect to come out of this research was this kind of recognizing that there might be different approaches to achieving net zero. So the approach that's kind of initially outlined is what we call net zero now, where, you know, you're building, essentially you kind of design it in a way that you kind of minimize all of the emissions at the outset. And then you apply your offsets, or again, close to or at practical completion. But you know, there are different approaches depending on the nature of the building. So if you've got, for example, an existing building, it might be that the case that you'd implement a series of approaches over the life of the building that would get it to net zero. Or for example, you might blend approaches in order to kind of get to that point. And one of the kind of key takeaways from the research was that actually, when we're thinking about net zero, although that carbon is such a significant component of delivering buildings now, that it should be up there alongside time, cost, and quality as kind of one of the fundamental constraints on development. And it kind of led to this idea that the golden triangle should be redefined as a carbon square. And we also kind of thought, well, actually, you know, this square might distort over in relation to these kind of different drivers, and that's something that's kind of captured in the toolkit that we've developed. It's also important that there was like a data component to delivering net zero, and that was to do with things like digital twins and materials passports, and the relationship of the BIM model to the upfront and whole life carbon calculations and those sorts of things. And another key part was circular thinking, kind of recognizing that iterative design process are kind of fundamental for delivering net zero, as is kind of taking lessons from post-occupancy evaluation and applying them to the design process. So when we're kind of summarizing this, we're in the guide, we've got 10 key points for delivering net zero. And the first is, as I kind of mentioned, fundamentally about taking a whole life carbon approach. The second is that when we're thinking about operational, it should be tied to monitoring and tracking rather than simply kind of designing for a set level of performance and then kind of walking away. It was also in recognizing that embodied carbon and an understanding of embodied carbon is kind of fundamental to it, and that as designers, we should be substituting materials or using carbon sequestering materials where possible. Tied to that is the idea of economy and efficiency and elegance, that actually it should be using only as much resource as is needed. The next one is recognizing that the performance gap is now much more than just operational energy, that when you kind of take a whole life carbon approach, that there is scope for a performance gap along each one of those stages, at the upfront stage, at the operational, when we're considering changes of use and those sorts of things. And it's also, we kind of need to recognize as designers that there are these different systems that will be feeding into our response to delivering net zero. And that's things like the national grid, but also systems of manufacture and construction. We need to recognise that the building users will play a fundamental part in delivering the net zero strategies, that carbon should be viewed alongside time, cost and quality as key constraints, and that net zero demands cyclical thinking, and that's kind of both at the level of iterative design, but also pulling in lessons from post-occupancy evaluation. And there was, you know, another kind of final key point was recognizing that we as designers have, we're able to influence clients beyond the brief, and that we have a capacity to steer and shape the expectation of what is achievable when we're kind of thinking about applying net zero. Okay, thank you.
Thank you very much, Simon. Just to let the panelists know that there are a couple of questions in the Q&A in case you're able to answer them once we go. And then next up on our panel is Kuchin. If you could share your slides, please.
Hello, I will share my screen. Can you see my screen?
Yeah, we've got it. If you could go full screen as well. Perfect, thank you.
Yeah, thank you. So hello, everyone. My name is Chuten Lu. I'm from the Bartlett School of Sustainable Construction. So my research is related to how to use digital technologies, especially digital twin, to improve the current built environment to be sustainable, resilient, and smart. So, and actually, I just started a KTP projects with BSI, British Standard Institute. So, I didn't have any thing to show at this stage, but I will show what my current research look like and how it connected to the KTP opportunities, and how it will improve the sustainability of the built environment. So I have been working on digital twins for many years. So not only focus on the theory and the framework and behind it, and also cover the values and also the implementations. So it mainly have the 3 stage for my research team. So firstly, how to create a digital twin, use very simple and convenient method. The second is how to broad the implementations of the digital twins, such as from the sustainability, from the smart and resilience aspect. So the next level is how to jump beyond the digital twins and to benefit for the societies and also the bigger broad goals. So the first one is how to develop a convenient way to generate digital twins. So the method developed by our research team is to use the current existing CAD drawings and also the collected images by digital cameras, iPhones and others. So these convenient devices, and combine with the characteristics and also the images collected by this kind of equipments and generate the building information model. So firstly, we will use the ORC algorithms detect the characters and build the coordinations of the whole layout of the buildings. And the second, use the images and basic on the image processing technologies, detect objects such as windows, doors, columns, walls, and beams, and detect this kind of informations and target objects, and combine all the informations from the modular 1, from the CAD drawings, and from modular 2, the images, to generate existing building information model for the existing buildings. So this kind of method is a kind of practical, efficient, and also accurate way to generate geometry digital twins, and also can update it. So the next case I would like to show is how digital twin can benefit for our societies. So how to build the relationships between the buildings, neighborhood, cities, and with our human via this kind of virtual and sustainable channel, and how to improve it through sustainable growth, health agent, intelligent development, and also flexible extensions. So this is the case I did when I was a research associate at University of Cambridge. So try to create the digital twins of at a campus level. So firstly, for the modeling layers, we used the vehicles based scanning and also fixed wing drone scan the whole West Cambridge campus, and organize all different kind of models in 3 layers. So the first layer is the campus layer. It is the LOD1, and the middle layer is building layers. We use building information model. And for some detailed aspects such as plant rooms and also pumps and other equipments, we use the scans and also CAD drawings to generate the detailed model. So for the besides the modeling layers and for the information layers, we use the IFC extension integrated different kind of database, such as real-time sensor data, the BMS, the AMS, asset management system, and the space management systems, and also linked with new established QR code systems. So we develop a kind of new extension data structure behind that. So we build a marching between different kind of existing database with a centralized FC extension. So that means we don't have to recreate or regenerate different kind of data sets, but all the data saved in their original spaces, and build a link between the center database with other existing database. We use the request query and response method to request different kind of data sets and for the different kind of purpose. So it covers different layer from the campus layer, building layer, and to access layers. So what kind of applications or implementations can support, the digital twin can support. So it can support the maintenance and repair task. It also can support for different energy demand forecasting and optimization in building and city levels. Yes. Okay, so we have different kind of implementations, such as the energy electricity predictions in campus and in building levels, and also some asset detections and predictions in the building levels. So I would like to, since the KTP projects should build the link between the theory research and also the implementation research. So this is a project I work with a company and I try to develop commercial products use digital twins for their daily management. So for instance, so you can control different kind of projects in around the whole country. And also it covers different kind of functions for the sites, such as space management, energy management, energy control, security, operation and maintenance, and also other equipment controls in real times, and achieve the sustainability and the smart targets. So also digital twin can be linked with different technologies such as extension abilities. So we extended with the AR technologies and to generate the more virtualized environments. And another project I would like to show is how the digital twins can improve the infrastructure carbon footprint using open social and technical ways. So this is the 5-stage method that we decided how to determine the carbon footprint for the infrastructures. And especially for the cases we use one particular part of the highways in the UK. So it have 5 stages. So from the initial project stage to the method and tools choosing stage, data collections and a carbon footprint analysis, and came to the carbon footprint presentation operation stage. So it can cover different from the material structures to the behaviors of the highway uses. So this is what we generated combined with the materials and structure and also behaviors of the highway digital twins. So this is how it look like. I will show the videos. So this is the final digital twin enabled carbon footprint management platforms for the highway systems, including materials and behavior. Thank you. So the next step for us is to, because as you can see from this modular, so the next step is to how analyze the weathers and the current climate changes can impact for our infrastructure systems. So I did a case funded by the WTW research networks, so analyze how the current climate changes, especially the floodings, can affected the infrastructures, especially the transportation systems. So we choose the London as a case studies. So a specific area of London. So it will be develop a kind of method basic on let me open the video firstly. So combined with the climate change, especially flooding and raining of landing areas, with the digital twin technologies, and how it can show a dynamic strategies for our transportations, and how to reduce the travel times, and how to design a dynamic open and closed strategies for our road systems. So currently, my research is not only focused on the theory aspects, but also focus on the how to transfer my research knowledge to the implementations, and also the different kind of implementations. So for instance, our digital twin maturity model has successfully been used by an Australia company called Aerocom. So this is the basic introduction about our current KTP projects, but haven't studied, just like get it, but haven't studied. So we would like to consider about the current markets, economies, regulations, and digital trend in the constructions, and analyze how the sustainable and low carbon adaptive manufacturing in constructions, and combine the current business with BSI, and hopefully next year or the next 2 years we can show some research results based on these KTP projects. So that's the end of my presentations. Thank you so much for listening.
Thank you very much. We're running out of time, but we do need to finish promptly. I guess everyone's ending their lunch breaks. So the Q&As have been answered in the live answered box, and we can always follow up later. So thank you to everyone for joining us today, and a big thank you to the panel for their time and contributions to this discussion. Sustainable Places is back next month. Sign up details will be in the chat, and we hope to see you there. Thanks very much, and goodbye.